Hello, beautiful people! So, I'm sure that many of you, since you started working with SwiftUI, have struggled with its limitations and the amount of workaround that you had to come up with. And one of these limitations, or let's call it issues, might be about the navigation link and the fact that the destination view gets initialized way before it's even needed. So in this video, we will be going through an example. We will be talking about the current behavior and we will be coding a solution. So let's do it. Let's start by writing a simple example of using a navigation link inside a list view. So just to reiterate what we have here, we have a simple data type of type ID, of type identifiable with an ID and an index, and just a list of integers from 0 to 99. And we're using this data source to feed the for each loop, where we have a list of simple text with the index number and the number that we get from here, and it's all wrapped around the navigation link, which segues into the destination view. Let's take a look at the destination view, and what I'm really interested here is the lifecycle. There's nothing really in this view except a simple text, just to have some kind of visual on the screen, but what I'm interested in is the lifecycle, where when is init called, and when is the body called, and when is the onAppear of this view called. Let's run the example just to visualize what we have here. So it is a simple list of integers, and if I click on one of them, I segue to another view. Now, let's take a look at the log. What we see here is that all the inits of all the views were called, even though I'm not using these views as of yet, and maybe I'll never use them. But we see that all the views were initialized, and only the body was called to the view that I clicked on. So, why is this behavior a problem? We see the app is loading normally, fast, all good, but this is just a simple text view that's initialized. Imagine you have a bunch of data here that you are gonna load. So let's write our data call, an API call. Let's have that written in a view model. So a destination view model. It's an observable object. So in here, we're gonna have our data. So let's say var data, or gonna have our results equal result. And we're gonna talk about that in a second. So let's initialize, or let's construct our data call. We're gonna just build a simple call using URL session. I forgot to initialize this array. So this is just a simple random URL that's just directly from the iTunes store. I'm just calling Taylor Swift for no reason, just randomly. So let's request equal URL request. URL session dot share dot data task with our URL. And here, let's capture data, response, error, in, and never forget to put resume. I usually forget this, and I spent a few minutes thinking, why is this not working? What's wrong? So let's unwrap our data. If data equal data, let's decode our response. Decode did response JSON decoder dot decode from response dot self from data. I'm pretty sure this should be a try. Okay, so now let's capture, if all's okay, let's reload our view. So we're gonna give this guy here some data. So dispatch queue.main.async self.results equal decoded response.results. So let's just see if it's called successfully. All right, all seems good here. If not, then just return. Shall item was never used. Why? What did I use? With request here. My bad. So here we're gonna go and call this add observed object var view model. Wait, no, this is a view model equal initialized. So let's call this API on init self.getData. So I'm not doing anything with the data, I'm not using it, I'm just calling it for you to see that all these APIs are called on runtime because all these views are initialized on runtime, which causes all these API calls to be made on runtime. You see, we're calling this here. So all these data are loaded unnecessarily, which can cause or will cause a lag depending on how big your destination view is in terms of data, in terms of content. So how do we solve this? By this meaning, how do we solve the destination view getting loaded directly from runtime, or directly when the parent view gets initialized, all the subsequent destination view gets initialized? What if we can do something here? Meaning that there isn't something just directly an API from SwiftUI that we can use to make this load in a lazy way, but what if we can do a workaround? So let's try to add a view that will act as a middleman between the source view and the destination view. And what if this middle view gets initialized, but it's just empty, that it has minimal to no impact over either CPU usage or RAM usage? And this middle view will be responsible to initialize the destination view when that is needed. So let's start by writing this. Let's call it the navigation lazy view content view. It's a view, of course. So in here, in the initializer, we are gonna get our destination view this way, escaping of content. Attribute navigation type navigation view does not conform to protocol view, of course, because it has no body yet. So var body bar, I wish, bar body, and not some view, it's set content. And in here we need to assign this view to a closure. So let's build. We will explain what's going on here in a second. Just let us finish writing this code. Self.build equal build. And then here let's call build. Wait a second to see what's going on here. I didn't include these guys. Okay, so we will wrap this destination view and let's watch what happens. Now we got nothing on our console, meaning that all the destination views were not initialized. But does this mean that nothing was initialized? Not really, because in fact this navigation lazy view was initialized instead of the destination view. So yeah, so it's initialized probably 100 times. So, but at least our data here aren't loaded unless we are calling the destination view. So let's call it. And here we see that it is initialized in a destination. It is loaded. It's called on appeared, and all just on demand whenever we needed it. So let's get back and see what happened here. What did we do? So in here we basically passed the destination view as a closure to this view. So what does this do actually? So with the auto closure attribute, we declared that we are expecting a view that will be enclosed in a closure. And thanks to the escaping attribute, we can store that closure as an instance variable to our struct. So by passing the view as a closure to a function, it won't be executed inside of it. And that's exactly what happened here. So we solved that problem of the navigation view destination that gets initialized even before it is needed. I hope this video was helpful. Let me know in the comment section if you had any other questions, and I'll be happy to help, and I'll see you in the next one.